Everybody, you don't see an issue with your calculator showing in Spanish or something. Okay, here's the second problem. People come to me, they say, Mr. Gens, my calculator won't graph. There's something wrong with it. It's never that there's something wrong with your calculator. It's always that there's something wrong with you. Your calculator does whatever you tell it to. So you didn't tell it to do something correctly, all right? So here's the first thing that happens. You're sitting in y equals, and you realize that you have a plot turned on. So if your plot is turned on, that can cause issues with your ability to graph. Because you're telling your calculator you want to graph these equations, but you also want to graph the plot. Well, the plot might not fit on the screen that you're wanting. So go up and take the plot off. Second thing that happens is people have some type of a window error. For example, you might have a value of 4 here. Who can tell me what's stupid about that? The minimum is bigger than the maximum, so you press graph and you've got no chance. Right? Pressing zoom 6, enter on quit. So enter on quit and then go zoom 6. Zoom 6 is a way to view a standard zooming window all the time. I'm sorry, I'm going to get out of this so we all see the same thing. But again, if we just go zoom 6, it'll bring you into a standard viewing window like this, so we can all see the same thing. The final thing that generally happens to people when they can't graph is somebody, or maybe, a lot of times, believe it or not, but you guys sometimes take these home and you don't put the cover back on it. And so it sits in your backpack, and this screen is not covered up. So all of a sudden buttons get pushed, and honestly, your screen's going to get dented and damaged in that situation. Always put the cover back on your calculator. But so I could go to Garrett right now, and I could go into his calculator, and he has no idea what I'm doing. But I'm going to play a joke on him because it's study hall and I'm bored and I got nothing to do. And I'm going to, go into y equals and type 2x. And so now I'm going to say, hey, Garrett, go into your calculator and graph 2x. See what happens. So Garrett has, 2x or something in his calculator. Oh, are you getting an error? Yeah, you are. So what I did to him is I put just a little decimal point down there. So now the calculator wants to graph all those things, but it also wants to graph a decimal point. And it can't do that. People are like, Mr. Gaines, there's something wrong with my calculator. Well, you got two options. You can either quit or you can go to the error. Let's go to the error. Press enter on go to, and it actually scrolls down and finds where the error is for you. It says, I don't like that. That's causing me a problem. Here's another classic one, okay? You've got this negative 2x guy right there. I'm going to change that negative 2x. I'm going to change it to a minus sign with the 2x. So instead of a negative sign, a minus sign. Now I go graph. It's going to graph the first equation. It's going to graph the second one. Now it tries to graph a minus 2x. And again, it doesn't like it. If you would have pressed go to, that would have helped out. So you can see the situation. Just go down and go to. It's going to find that it doesn't like the subtraction sign, make it negative, and now everything would work. Okay, get your contrast. Go second quit, so you're at a blank screen. Everybody should be at a blank screen. And now go second up, second up, second up, or second down, second down, second down, and change the contrast on your screen. And find the contrast that you like. What is the contrast setting that you like? Do you like your contrast at a 4, a 5, a 2, a 6, an 8? What are you liking? Second up. Is it making it darker? Oh boy. Okay. Going to y equals and type in those four equations. Y sub 1, y sub 2, y sub 3, y sub 4. We're going to use these four graphs in order to do some examination. Everybody got them? Okay, so I'm going to press Zoom 6. Zoom 6 is how we always get to a standard viewing window. How many equations do you see? 3. How many did we type in? Why are we missing 4? Why are we missing one of them? Why is the window too small, Blake? Which one? The one that is the plus 48? Yeah, because the y-intercept is 48. It's way up there somewhere. So you only see 3 of them. So just notice that it's kind of like you're looking at a map and you see Albert Lee. You're like, hey, where's California? Well, you better zoom out if you want to see California, right? So it's the same type of principle. So make sure you got that ready to go. So we're going to go back into y equals, and you're going to go over, and you are going to unhighlight y sub 2, y sub 3, and y sub 4. So that way it can have all 4 typed in, but I'm only going to view a couple at one time. I'm just going to view the very first one, actually. Thank you. Oh, boy. Okay, so here we have it. I'm going to graph this. You can see my cubic as it's graphed. And if you look into y equals, you can see I have that line on the side. So it drew what we call a connected graph. But I have options to display how I want things to look. So I go over to this side and I press enter on that. And notice what happens. I get a darker line. Now as I press graph, how does it change? What is your question? Yeah, so those of you who have your fancy-dancy LED calculators, you not only get to select the type of the line that's shown, you also get to select the color. Magenta, navy, yellow, whatever you want. Then probably scroll down, I'm guessing. Now it goes to the line. You can change all sorts of things there. And then after you select the one you want, you can, there you go, you got your bold one. Now go down to OK. Now press graph. There we go. What I want you to do, Emma and Blake, I'll come back and help you now. I want you to go into y equals. I want you to move over, and I want you to select all the different things and see what they do with the shape of your graph. Go ahead, play around, have fun. Okay, so those are just kind of the 7 general types of graphs you can produce. Bold, shade up, shade down. You can have this ball or a ball with a line. You can have dashed. Which one do you like the most? You like dash? And when might you bold something? If it's more important, maybe if it's a parent function. Parents? When might you shade something? Inequality? When might you use the ball or a dot? It's hard to see when that would happen, but when you're doing motion or what we call parametrics, parametric equations involve time and motion much of the time, and so you haven't seen that yet, but yeah, that's an option there. You can actually play around with kind of how this stuff is viewed. I'm going to go back to this, and I'm going to just grab a normal graph, so a normal line graph, and zoom standard, so I'm in a normal viewing window. And this may be something you don't realize about your calculator, but you can move around the cursor and be able to find different x, y values for where you're located. So you can see you have a location here at negative 0.85 and 2.25, so on and so forth. But you can also press trace, and then as you move left to right, it's going to find the values for you along the graph the entire time as you move left to right. Okay, everybody know your trace option? We all good? If you hit second format, you can change the way that the graph looks. So we're never going to change it from rectangular, but look at coordinate on or coordinate off. If I go and select coordinate off, and I press graph, now when you move around, you don't get anything. It doesn't produce X, Y values. Or if you press trace, again, you don't get any X, Y values as you're moving through there. Okay. If you're in format and you switch from grid off, well, I'll put the coordinates back on. If you switch from grid off to grid on, now as you press your graph, you can tell you get pixels, at every location. If I go second format, I take that grid off, and now I go to axes off. Now as you look at your graph, produces the graph, but no X or Y axis. You might say, why would you ever want to do that? Well, for example, in calculus, we're graphing 1 divided by x to the 4th. People want to see that graph, but if they view it in a normal window, the graph actually looks like the x-axis for much of the location. Now that I take the axes off, you can see most of it, which is, then helpful. Other format options, your label on, label off, or expression on, expression off, usually really isn't that helpful. I'll take the expression off so you can see what that is. But so we look at the graph now, you can see I get my graph, but when I trace it, it doesn't. It tells me it's equation 1, but it doesn't tell me which expression it is. Whereas right now, if I go into format, I put the expression on, and I go to graph. Now you can see I have the actual expression. Okay. So those are just some small things. All right. Well, let's see what you're actually going to use. Okay. So this is where this is all that stuff is that's just kind of fun stuff. Now we get stuff like you have to know how to do this in order to be able to do our next assignment, okay? And tests. Like this is stuff you're going to have to know how to do, okay? So here we go. I want you to just select y sub 1, so make sure that's the only thing selected. And I want you to zoom standard, zoom 6. How many times does that graph cross the x-axis? What do you think? Twice? Once? 3 times? Would you be willing to bet $1 million that it crosses 3 times? Oh, wow. You're that confident. So you're that confident that it doesn't simply just come here and touch tangent. You think it actually crosses. Wow. Well, yeah, I'm just thinking you're willing to wager that much money. Oh no, that might be the tick mark, because it doesn't always. I mean, it's an estimated value. You know what I mean? So it could very much be above it. If you do look at the table, you'll find out for sure. But have you looked at the table? You did already. Okay. Here's another way to do it. If you zoom box, this is what I want to teach you. When I zoom, I like to zoom as a box. I don't choose in or out. I zoom as a box. And you can see in the middle here, it's blinking. And if I move that cursor over here, you can see I now have a location for one corner of my box. I press enter and it locks that corner in place. Now I go down and over, and I press enter, and it zooms in the exact box I gave. And you are right, Alex. It does cross 3 times. You'd be right to go to Vegas. But most people say it's really hard to tell. And as you can see here now, I am convinced it does cross for sure 3 times. Everybody agreed? Okay. Could give you another zoom option that's kind of fun. If you zoom 6, it gets us back to a normal viewing window, so zoom 6. And now zoom, obviously you can do in or out, but what's number 4? 4 says zoom decimal. So I press 4, and it looks like it zoomed in. In order to see what zoom decimal actually does, you have to move around. What do you notice about when I move around? It's moving by tenths. It takes your pixels and it makes it so that each pixel is exactly 1/10 of a unit in that situation. And it's kind of cool now that you are in zoom decimal. If you decide I would like to zoom out of that decimal, it will maintain the same decimal option, but it just increases the decimal. So now the decimal is every 0.4, as you can see. And so if you want to, you can always work with the decimal formats as well, which some people like. Okay, go back into y equals and deselect the first one. And I want you to select y sub 2 and y sub 4. Does anybody know if I graph y sub 2 or y sub 4? Anybody know what the graph looks like? They're just lines. What do you notice about the slopes? We have 1/2 and we have -2/1. They should be perpendicular because they are opposite reciprocals. As I graph them, zoom 6, as I graph them, do those lines look like they are perpendicular? Perfect 90-degree angles? No, if you hold even a 90-degree angle up to it, definitely not the case. That's because your graphing window is a rectangle, it's not a box. So if you zoom as a square, number 5, you can see in this situation, do they look like they're perpendicular now? They sure do. And if you hold your edge up to this, you can see it is at a perfect 90-degree angle. So zooming as a square can help if you want to see things that are truly proportional. Now go into y equals and deselect y sub 2 and deselect y sub 4 and instead select y sub 3 and go zoom 6. Blake brought this up before. Why don't we see the third graph? The y-intercept is up at 48. Maybe the whole graph is shifted way up there. So here's a way to see the graph, and I discourage you from doing this, but in a worst case scenario, here's what you do. You zoom, and you move down to zoom fit. A zoom fit option will make a window that finds that graph. I hate this option, but sometimes people have to use it. Hey, great, I see the parabola. I think that there's a better option, okay? I really do think that there's a better option. If I'm seeing zoom 6 or zoom standard and I can't see it, I should think about the graph. As I go into my window, my y max is 10. That's not going to see the y-intercept, is it? What should I maybe change my y max to? 50 would allow me to see a small portion of the graph. I'm actually going to go up to 100. And I'm going to go down to -100. And I've changed my, and as I graph that, you notice that I can now see a portion of the graph. Why is the y-axis so dark? There's a lot of tick marks. As you look at your window, it says that you have a tick mark every unit. Well, what if I put a tick mark every 20 units? Now you only have 5 tick marks on the top and then 5 on the bottom. That way you can adjust your graph accordingly. Go back into your calculator and just select y sub 1. Get rid of y sub 3. And go ahead and zoom 6. Are you guys familiar with this notation, f of 5? What does it mean to try to compute f of 5? That means what would you get if you plugged 5 into the function? So you could go here and you can plug 5 in for x, cube it, minus 2.1 times 5 and plus 1. Or you could use a different option. Second, calculate. Your calculator has amazing calculation values. We are going to go through 5. The other 2 are for calculus class. These 5 are very handy. You're going to press enter on value. It asks what you want x to be. Zoe, give me a number. 3. Plug in 3, and f of 3 is 21.7. just press 5, and it calculates that f of 5 is 115.5. Jack, give me a number. 8. F of 8 is 496.2. F of 11. Oh, hey, didn't like 11. Anybody know why? Because of my window. If I change my window so my x max is 12, now I can go ahead and calculate that value. So I go to my graph, it's now extended to 12, so if I press 11, it will find 11. If I press 12, it will find 12. If I press 12.0001, it will not find it. It's got to be within your window range. Let's change our window. Go into y equals and change it so it's -3, +3. -3, +3. Make a 3x3 window manually so that your graph looks just like this. Once again, how many times does it appear that crosses the x-axis? 3 times. I'm going to do 1 for you. You're going to do the other 2 on your own. Or if you have a partner, you should do 1 and then have your partner do 1. So I'm going to find this spot. It's called a 0. Where it crosses the x-axis is called the 0. We're going to compute that. Second, calculate number 2, 0. What's your calculator asking you right now? What is the left bound of your 0? So I'm going to move over to my 0. So it looks like I'm about at that spot. And now I move to the left of it. I move to the left till you're confident you're to the left of that spot. And I press enter. You can see it gives a triangle to say you're to the left of that spot. Now, what's it asking for? So move to the right. You have to make sure you cross the x-axis in the meantime. Press enter on that, and you can see that you are across that side. And it's asking you to now guess. Don't worry about guessing so long as you're somewhere close to that spot, and it will find it. -1.645. You go ahead, find the other 2 on your own. Go. Okay, what are they? I got -1.645. What's 0? 0.559. And then what? Excellent. Sure. Yep. Sorry. Okay, now let's check this out. As I look at the graph, doesn't it kind of look like there's a top spot and a bottom spot to this graph? Like there's almost like a maximum and a minimum, like you have a parabola that goes upside down, the parabola goes right side up. We can actually find those values. And so we're going to find the minimum, number 3. So second, calculate number 3. Okay? And you can see your calculator is asking for your left bound of that minimum. So what I do is I go over to my minimum. There I am. And I move to the left. I move to the right. And I press enter on guess. And it tells me the minimum has a value of 0.83, -0.17. What I would like you to do right now is on your own with your partner, try to find the maximum. So if you look at y equals in that graph, we want to find the maximum spot. Try that one on your own. Go. Everybody confirm that? There's another option in your calculator. That's pretty cool. If you go into y equals and you have y sub 1 selected, and we also select y sub 2, select y sub 1 and y sub 2. And press graph. How many times do those intersect? 3 times. We can find the intersection point. Second, calculate, and you choose number 5, intersect. I'm going to first move close to the first point of intersection. So I can move to the left. There we have it. And it asks if this is the first curve. Yes, it is. I press enter. It asks, is this a second curve? Notice it changed y sub 2 is equal to 0.5x. Yes, that's my second curve. Press enter. Guess. I don't need to guess. Just press enter on guess. And it calculates that this point of intersection is, in fact, negative 1.77, negative 0.88. You're going to find the next 2 points of intersection. Simply just move your cursor over near the other point of intersection and then go second calculate intersect and try to find those. Go ahead, see if you can work through the next 2. Okay, what were your other 2 coordinates for intersection? What did you get? And 1.36 and what? All right. Great. So you've learned about these 5 options that exist. Another option you want to learn about is your table. Go second graph, it'll bring you to a table. Second graph, it'll bring you to a table. My table right now is really ugly, okay? I'm going to help you with your table here. Go second table set. Second table set. So it's a second window. Second window. Gina, give me a number. 3. So I'm going to start the table at a value of 3. This is delta table. Delta means what is the change that you want in your table. I'm going to have a change of every 1, meaning the next number is going to be 4, then 5, then 6, then 7. And I'm going to set both of these to automatically generate. So now, when you go second table, notice your x values start at 3 and they go up by 1. It shows the values for y sub 1 and the values for y sub 2. So Brecken, you were making a point before about looking at the table, right? Suppose Brecken wanted to see the values for 0. They're not up here, but he could just scroll backwards and get to 0. Suppose he wants to see the values for 256, but he doesn't want to scroll down to 256. Then just change your start value to be 256, and sure enough, then you produce all those values there. Most of you don't want that option. What you guys want is you want to, so like SB right now, if we went to her calculator and she's working with limits, she wants to be able to type numbers in here, right, SB? That's what you want to be able to do. So what she does is she goes into table set and she just goes down to this independent variable. Your independent variable is X. You want it to ask the value. Go over and select ask. And now that it's selected on ask, then go ahead table and you type in the values that you want for X. So you can type in 3, you can type in 9, you can type in 12, type in 13.4 or 57 or whatever you want, and it's going to produce the values for you. Having your table values set to ask is a very important piece to be able to do. Just some general things you weren't aware of. If I press mode, you can go down to horizon and it's or horizontal, and we press graph. It'll show the graph up there, and then it will also leave room below for you to do computation, like 98 times 96 is 9,408. Or if you'd like to, you could go to mode and you go down to G/T and you select that. And when you select that, you look at your graph and it brings up the table on one side and the graph on the other side for you. It is sick. I showed you last year, just forgot you were tired and sleeping. So we've got that. There's common sense things that people just aren't aware of. Suppose I wanted a 3 in front there. You could go second insert, put a 3. Yeah, that's what INS means, insert. I'm sorry. The last thing I have for you is if you go to YouTube and you search my name and you search quadratic formula, I have a video. This is your assignment tonight. Is to type in and trust me folks, like what I say, like all this stuff about intersect, maximum, minimum, zeros, you're gonna have to do it all. Okay? So if you need to go back and rewatch a video or come in to get help on your calculator, you're gonna have to do that. Okay, it's your job to know how to use this device. Um, but here's another thing that's kind of cool. You can actually program stuff that sits into your calculator for functional use. So you can see here I'm typing in things like b squared minus 4ac stored as d, so on and so forth. So I have a program that I show. It just takes 4 minutes and 2 seconds. You just Kevin Gens quadratic formula, and a couple hundred people have viewed it. Should be like 2 billion people have viewed it because it's so nice and easy. Shortest formula I can ever come up with. And what it does is you program it to actually calculate the values from the quadratic formula. It finds 3 and -1. You cannot tell me it's too difficult. I had my daughter do it in 6th grade. Okay? So we're able to do it. Okay? Find it, try plugging the values in, 4 minutes, 2 seconds. I just got tired of people going off to college and emailing me saying, hey, Mr. Gens, I can't remember how to do the quadratic formula in my calculator. Can you please teach me how to do that again? And so I just made a video so they could find it. YouTube and the internet are wonderful opportunities. By the way, this is just one program. I used to have, my calculator, I used to have about 20 different programs in there I type things in for. Distance, slope, midpoint, all that stuff can be typed in. So find it. It's yours. Again, in order to do your assignment tomorrow, you will have to have a graphic calculator. Okay? Bye, Hannah. We miss you.